We're going to start looking at two concepts called slope and y-intercepts, and we're going to look at them in terms of graphs. One thing to keep in mind is slope is in the real world situations often referred to as a rate of change, whereas in equations it's referred to as slope. Either way, it's going to be a change in our dependent variable divided by a change in our independent variable. This is going to be something we want to keep in mind when we start looking at the formula for slope. This is where the formula is going to come from. But for now, we're going to just, like I said, look at it from a graph. We won't worry about a formula yet. When we look at slope, the symbol we use is m. Our y-intercept is going to be defined as the point where on the graph where we cross the y-axis or intersect the y-axis. When we look at a graph, there's four types of slopes we can have. We can have a positive slope, which when reading from left to right points up. We can have a negative slope, which from reading from left to right points down. We can have a slope of 0, which is just a flat line, there's no incline. Or we can have an undefined slope, which is straight up and down, or a vertical line. One way to help you remember slopes is this little kind of saying here. Slope is easy and fun, it's rise over run. That's the concept we're going to use when we look at graphs. The rise being the change in our dependent or y variable, the run being the change in our independent variable. So let's go ahead and look at some examples where we put that in place. On each of these, we're going to find the y-intercept and we're going to find the slope. So if I first find my y-intercept, I'm going to pick out the point where I cross the y-axis. Well, notice I cross right here. Well, that's at a x value of 0, since I go left or right 0, and I go up 3, so a y value of 3. So my y-intercept is the point 0, 3. If I now try to find the slope, I've already labeled or pointed out one point. I want to find another point on my graph. So I notice I also cross through this point here. Notice I select a nice point that's easy to read on the graph. I'm not choosing one of these points that are in between grids, but I take one that's right on a grid line. And now I'm going to ask myself, how much should I rise and how much should I run to get to this? And my slope is going to be that rise over that run. Well, it looks like to go from this point to this point, I rise 1, 2. So my slope is easy and fun. It's rise, which is 2, over my run. And it looks like to get to here, I run right 1, 2, 3. I'm always going to go from left to right. And notice, as I had just mentioned above, reading from left to right, this is a positive slope. It is going up, and I get a positive 2/3 for my slope. Doing the same thing on my second example. I first find my y-intercept. Well, again, that's just going to be the point where I cross the y-axis. Well, it looks like I cross the y-axis here. And again, it looks like I have I'll go over 0 on the x-axis and up 1, 2, 3. So again, my y-intercept is 0, 3. And looking at this line here, it's just a flat line. So I remember from up above that if my slope is just a flat line, it means my slope is a value of 0. Looking at the next two. Again, I go ahead and I notice that my y-intercept is where I cross the y-axis. So again, notice that I go left or right 0. In fact, whenever I'm on the y-axis, my x-axis is, or my x value is 0. We're actually going to use that fact in a later objective to help us find y-intercepts from equations as opposed to from graphs. And then I count how many I went down. I went down 1, 2. So I go 0, negative 2. Again, to find my slope, I'm going to need another point. So let's see, I'm going to try to find a nice point. This looks like a nice point here. And I always read from left to right. So notice in the first example, I rose 2, whereas in this one, when I'm going from left to right, I'm going to go down. So sometimes you'll hear me say I rise down. Essentially what it means is I'm going to have a negative on my rise. So let's see, if I count how many I go down 1, 2, 3, 4, 5, 6, 7, looks like 7. I'm going to say I go down 7, and then my run, I'm going to go right for my run. I always go left to right again, and I go over 1, 2, 3. So my slope is negative 7/3. Looking at one more example here, and then I do have one application problem. Again, first thing I'm going to do is label my y-intercept. So it looks to me that my y-intercept goes over 0, and it goes up 3, so I'm at 0, 3. To find my slope, I need another point. Looks like a good point there. Again, I always go left to right, so it looks like going left to right. I'm going to go down 1, and I'm going to go over 1, 2, 3. So my slope is negative 1/3. Looking at one final example, I'm still going to find my y-intercept in my slope. Well, I notice that this graph doesn't dip all the way down. It doesn't extend all the way down like my other graphs have. Well, if I look at my units, I have time in hours and distance in miles. Hopefully it makes sense that I don't want to use the negative time or the negative distance. So it looks like my y-intercept right here is just at 0. So I'm going to go ahead and say my y-intercept is at 0, 0. I go over 0 and I go up 0. And then my slope, I would need another point. So suppose I need this one here. And there's lots of points to choose from on this graph. Looking into account, I don't rise 2. It looks like I rise 50 and then I rise 100. And it looks like I run 1 and then I run 2. I always reduce, so I get 50. And looking at my units, it looks like on top I had 100, which came from the miles, and on the bottom I had hours. So I'm going to go ahead and say that this is 50 miles on top per hours on the bottom. And that is it for finding slopes. So again, it's easy and fun. It's rise over run. Don't forget you always read left to right, and there are those 4 different types. You can get a positive, a negative, a 0, or an undefined slope. Make sure you have these notes with you in class so you can use them as a tool with your practice.